Hello students, IBM is here with another episode of Learning Physics, and today I want to take you to AS Physical Quantities, Units and Measurements, and this is going to be part 4 of the solved past paper questions. I think in part 3 we stopped on page 22, I think, and we were going to answer this question. So I want us, without wasting any time, start with this question. The speed v of waves on a stretched wire is given by this equation, v equals to t power p mu power q, where t is the tension, so that is a force in the wire, and mu is the mass per unit length. So mu is equal to mass over length. So what are the values of p and q? So v is called speed. The base units are going to be meters per second. I will just use homogeneity and equate the units. T is tension, which is a force, so the units will be kilogram meters per second squared for T, but this is raised to power P. And mu is mass per unit length, so mu is going to be mass, which is kilograms, per unit length is going to be per meter, and this is raised to power Q. So I want to find P and Q, so I will use to find P. I can use kilogram to find the P. Let me use S to find P. On the left hand side I have S power -1, and on the right hand side I have S power -2 times P, which is -2P, which means that P is going to be equal to 1 over 2. I equate the powers mathematically. So P is 1 over 2 positive. That means I eliminate A and B because these ones are negative. Then I can now use kilograms to find Q. For example, on the left hand side there is no kilogram, so I can say kilogram power 0 on the left hand side because kilogram power 0 is 1. Then on the right hand side I have kilograms power P in the first bracket, then kilograms power Q, so it will be P plus Q. We add the powers. So this means 0 is equal to P plus Q, so 0 is equal to P, which is a half, plus Q, which we want to find. That means Q is going to be equal to, you take a half the other side, it becomes negative a half. So Q must be negative a half, so our answer is going to be C. The diagram shows a force F. P is the horizontal component of F at an angle theta to F. Remember, the horizontal component P must be equal to F cos of theta. We resolve F in the horizontal. So it means when theta is 0, P is equal to F. Our graph starts from a certain value on the y-axis. So P cannot be 0, so B is out, C is also out. When theta is 0, P is equal to F, so the graph starts on the y-axis. Then when theta is 90 degrees, P goes to 0 because cos of 90 is 0. So both A and D are actually going to 0. However, we can check whether D is the correct answer or is the correct answer by checking any intermediate value such as cos of 30. We can find cos of 30 or or cos of 60, which is a half. So it means when theta is equal to 60 degrees, when theta is equal to 60 degrees, let me divide this into 30 somewhere here, and 60 will be somewhere here. When theta equals 60 degrees, cos of 60 is a half. The cos of 60 is equal to a half. So it means P will be equal to a half of F. So at 60, P is going to be a half of F. So a half of F, this is F. So P should be approximately a half. Halfway is around there. We can also check here, halfway, if 60 is around here, halfway would be somewhere here. That means this graph is wrong. So I have checked 60. You could also check 30, but I've checked 60, and therefore the answer is going to be A. Of course, this is a cosine curve that we are familiar with. A student wishes to measure a distance of about 10 centimeters to a precision of 0.01 centimeter. That is a vernier caliper, I think, because if it is a meter ruler, it will be 0.1. A micrometer screw gauge will be 0.001 in centimeters. A tape measure that would have almost the same as a meter ruler, so our answer is going to be D, which is 0.01 centimeters. That is the instrument which gives us that precision, because the least count or the smallest value on a micrometer screw gauge is a vernier caliper is 0.01 centimeters. Which unit is equivalent to the Coulomb? Remember, Coulomb is a unit of charge which charge is I times T. So I times T can be ampere seconds. We don't have it here. We have ampere per second, so this is wrong. Then we can also remember that EMF or voltage PD is equal to the energy or work done per unit charge, and meaning that charge is going to be work done over PD, which work done is in joules and PD is in volts, so joules per volt. The answer is going to be B. Which row shows a quantity and an incorrect unit? Efficiency, that one has no unit. Moment of a force is Newton meter, not newtons per meter, because moment of force is the product of force and the perpendicular distance. So force times perpendicular distance, that is Newton meters. So that means this is wrong. So our answer is going to be B. Two forces of equal magnitude are represented by two coplanar vectors. One is directed towards the east. One is directed towards the east, and the other is directed towards the north. One is directed towards the east, the other is directed towards the north. What is the direction of a single force that will balance these two forces? So we just find the resultant of these two forces, but they want the direction. So the direction of this should be in between here. That is towards, it is either towards northeast. No, it can't be northeast. Two forces of equal magnitude, they have the same magnitude, are represented by two coplanar vectors. One is directed towards the east, and the other is directed towards the north. So let me fix one vector, such as this one, towards the east, and on its head, I add a vector which is towards the north. Remember, they are equal in magnitude. So these ones are forming an anti-clockwise loop, so the resultant must be the other way around. So the question is, what is the direction of a single force that will balance these vectors? So we have the resultant of these vectors is this will be the resultant. That means the force which will balance these two must be in the opposite direction to the resultant. So the force which will balance these two must actually be in the opposite direction to the resultant. So I think that will be southwest. That is southwest. If we draw a compass, I think this is southwest. So the answer is going to be D. The resultant is northeast, which means the one which balances northeast is southwest. So our answer is going to be towards the southwest. The answer is not towards the northeast, because when we join the two vectors head to tail, they form a loop which is anti-clockwise. So the resultant is the other way around. This is the resultant. So if this is the resultant of the two vectors, then we need a vector which will balance that, which will cancel out that resultant, and it is this one in the opposite direction. So that is why I'm saying it is towards southeast. When you look at the compass, this is southwest, not southeast. What is a unit of stress? Stress is force over area, and force is kilogram meters per second squared divided by area, which is meters squared. So meters over meters squared, I think it becomes kilogram per meter per second squared. So the answer is going to be A. Physical quantities can be classed as vectors or as scalars. Which pair consists of two vectors? This is a scalar. This is a scalar. This is a scalar. So the answer is C. Although electric field strength was removed from the from AS, electric field strength is a vector quantity. Two dogs pull a sledge along an icy track as shown. Dog X pulls with a force 200 newtons at an angle of 65 degrees to the front edge of the sledge. Dog Y pulls with a force of 120 newtons at an angle of 45 degrees to the front edge of the sledge. What is the resultant forward force? So we just resolve in the horizontal, in the forward. So this one will cause a forward force of 200 newtons because the angle is this one. So I will say it is 200 sine of 65, or I will say 200 cos. I can find the angle with the horizontal, which I think is 25. So it can be 200 cos 25. Then for this one also it will be forward, which will be 120. When I use this angle 45, it will be sine 45. Fortunately, the sine of 45 is the same as the cos of 45. So this can also be 120 cos of 45. Okay, so we now find the total forward force. So the resultant force is going to be, I will just use one part, it will be 200 sine 65 plus 120 sine 45. So 200 sine 65 plus 120 sine 45. So that gives me 266, which is approximately 270. So this is approximately 270 newtons to two significant figures. So the answer is C. In the circuit shown, an analog meter is to be calibrated as a thermometer. The ammeter is connected in series with the thermistor. The thermistor is a component with a resistance that varies with the temperature. The graph shows how the resistance R of a thermistor changes with the temperature. Which diagram could represent the temperature scale on the thermometer? So first of all, you notice that this part here, there must be a decrease in, this part is indicating because the resistance is decreasing, then it shows that the change in current increases. It must show an increase in change in current. And this part here is showing that the resistance is becoming almost constant. So this part here, it must indicate that the change in current is going to be smaller, because here the change in current is very small. Here the change in current is greater, is bigger, and here the change in current is smaller, because you see that here the gradient, actually the gradient is decreasing. So the distance, the distance between the values on the scale must go on decreasing. Then somewhere here they must be very close to each other, because the change in current is very small, because the gradient is becoming almost the same. So this means the answer is going to be A. Why not B? B is showing that we are starting with a small difference in current, yet here the gradient was decreasing, meaning that the change in current was increasing. So B is going to be wrong, because here there is a small change in the scale readings, and it is showing that at the end there is a greater change in the scale readings, yet at the end the change in the current is very small. Then this one is showing that there is a greater change, and it uniformly changes, it uniformly decreases until we reach zero. But unfortunately, we are not reaching. We're not even reaching zero. So that means this will not, because the line is not perfectly horizontal. This one is showing Okay, this one is showing a decrease in what? In current. Yet the current, as the resistance decreases, the current must be increasing. This one is showing that there is an equal interval between 180, 60, and so on. So which means that here the resistance was constant, yet it wasn't constant at all. So D is wrong. So here it is. This part here of the scale is indicating the greater change in a greater fall in resistance. Then the other part is showing a smaller fall, a smaller change in resistance, which corresponds to a smaller change in current. So the answer is going to be A. A sheet of gold leaf has a thickness of 0.125 micrometers. A gold atom has a radius 174 picometers. Approximately how many layers of atoms are there in the sheet? A sheet of gold has thickness 0.125 micrometers. That is the thickness. And the radius, a gold atom has a radius of 174 picometers. Approximately how many layers of atoms are there in the sheet? So let's have the same unit. Let's have the same unit here for thickness. We have 0.125 times 10 power negative 6. And then I will divide this by the radius of a single atom. Or I can even, because a gold atom has a radius of this, so the diameter is that by 2, because we want to approximate how many layers of atoms are there in the sheet. So this, I'll just first of all divide this by 174 times 10 power, pico is 10 power negative 12. So 0.125 exponent negative 6 divided by 174, this is negative 12. 174 exponent negative 12, which is this. Remember, this was radius, and diameter we multiply this by 2, so I'm going to multiply this one by 2. So I will still divide the answer by 2, which gives me 359. So this is approximately 359, which is approximately 400 to one significant figure. So the answer is C. Why isn't it 700? Because we cannot use the radius to estimate one atom, the size of one atom, but it is easier to use a diameter, because if this is a gold foil, then one atom compared to another layer of atoms, we can easily estimate the diameter. So that's why I multiplied this one by 2 to get 559. So that is approximately 400. What is the best way of describing a physical quantity? I think this is not the first time we are seeing this question, but a physical quantity must have a numerical magnitude and a unit. Magnitude and a unit, so the answer is going to be B. It should have a magnitude and a unit. Which pair includes a vector quantity and a scalar quantity? These are both vectors. This is a scalar, this is a vector, so our answer is going to be B. People always think that kinetic energy is a vector quantity, but that is not true. Which pair includes a vector quantity and a scalar quantity? These two are both scalars, these are both scalars. Okay. A force F acts at an angle theta to the horizontal. What are the horizontal and vertical components of the force? So we resolve this to the horizontal. Resolving to the horizontal, that is automatically, by now you should be an expert. It is automatically F cos theta. Resolving it to the vertical, it should be, this is F in the X. Then F in the Y is going to be F sine theta. Of course, if you're a mathematician, or even if you're not a mathematician, you will notice that our answer should be A. Why? First of all, in the horizontal, we eliminate C and D because F sine theta, and these ones are showing that the horizontal is F sine theta, it should be cos. But then, on the vertical, you can check. Put in your calculator sine of 90 minus any angle. You'll get the sine of the cos of that angle. That makes this one also to be wrong. The sine of 90 minus theta is the same as cos of theta. That means this is the same as saying f cos theta. The cos of 90 minus any angle is the same as the sine of that angle. So this is the same as f sine of theta. So our answer is going to be A. You can check theta by putting there a small angle such as 30 degrees and verify that. What will reduce the systematic errors when taking a measurement? A. A is saying adjusting the needle. Remember, systematic error is with the instrument. If you don't remove or if you don't cater for that systematic error, it will always appear in the measured in the measurement. So adjusting the needle on the voltmeter so that it reads zero when there is no potential difference. That when we are removing a systematic error. That is removing a zero error is removing a systematic error. So that means I don't need to check the other values, the other alternatives. Measuring the diameter of a wire at different points and taking the average, that one reduces random error. Reducing parallax effects, that is reducing random error. Timing 20 oscillations, that one also reduces a random error. The radius of the Earth is approximately 6.4 times 10 power 6 meters. And the radius of the Moon is approximately 1.7 times 10 power 6 meters. A student wishes to build a scale model of the solar system in the classroom. Using a football of radius 0.1 meter to represent the Earth. Is going to use a football of 0.12 meters. That is, I'll just change that to centimeters. The radius of the ball is 12 centimeters. That means the diameter is 24 centimeters. So the student is using this as the Earth. And we can compare the radius of the Earth with that of the Moon. So the radius of the Earth is equal to 6.4 times 10 power 6 divided by 1.7 times 10 power 6 times the radius of the Moon. I'm trying to find how many times the radius of the Earth is bigger than that of the Moon. So that is 6.4 divided by 1.7, which is 3.7. That is approximately 4 times. So the radius of the Earth is approximately 4 times the radius of the Moon. So that means the radius, the representation here should be something which has a radius that is a quarter that of the Earth. So the radius of the model of the Moon that we need here. So the radius that I need here, or I need an object whose radius is going to be equal to 12 divided by 4, which is going to be equal to 3 centimeters. So I need an object whose radius is 3 centimeters to represent the Moon. A basketball cannot have 3 centimeters. A cherry ball is bigger. A golf ball has slightly higher radius. Then most likely this is going to be a tennis ball. So the answer there is going to be a tennis ball with a radius of very close to 3 centimeters. When a beam of light is incident on a surface, it delivers energy to the surface. The intensity of the beam is defined as the energy delivered per unit area per unit time. What is the unit of intensity? So intensity is equal to energy delivered per unit time, that is per unit area. So we put area in the denominator, per unit time, we put time in the denominator. At this point, we know that the units of energy are kilogram, meters squared per second squared, divide by the units of area, which is meters squared, then divide by time, which is seconds. Energy delivered per unit area per unit time. So m squared has cancelled, so it becomes kilogram seconds power negative 3. So our answer is going to be D. This is kilograms, s goes up, it becomes s power negative 3. Kilogram, s power negative 3. We subtract the powers. A ship is traveling with a velocity 8 kilometers per hour in a direction 30 degrees east of north. What are the components of the ship's velocity in the east and north directions? So a ship is traveling with a velocity in a direction 30 degrees east of north. So if this is north, if this is east, so 30 degrees east of north, this is going to be here, 30 degrees. So the ship is traveling in that direction, 30 degrees east of north. What are the components of the ship's velocity in the east? So we resolve this in the east. So this is 8 kilometers. So in the east, it is going to be 8, either 8 sine 30 or 8 cos 60. In the east, I'll call this one V in the east, which is V in the x, is going to be 8 cos 60 or 8 sine 30, which is 4. So in the east, the answer is 4 in the east. So C and D are out. Then in the north, it is going to be 8 cos 30. V in the north is going to be 8 cos of 30. And 8 cos 30, 8 cos of 30, that is 6.9. So our answer is going to be B. So this is 6.9. So our answer is B. A micrometer screw gauge is used to measure the diameter of a copper wire. The reading with the wire in position is shown in diagram 1. So here there is a wire. Let's first take the reading. The main scale reading is this is 0.51.52.5. So that is 2.50 in millimeters. Of course, the micrometer screw gauge will measure to millimeters. Then the thimble scale reading, that is the scale which rotates. The other one is normally called the sleeve scale, and this is the thimble. So this is 5, 6, 7, 8, 9. So this is where we have the 9th division is the one perfectly in line with that central line. So the sleeve scale reading is always divided by 100. So this is going to be plus 0.09 in millimeters. So this gives us 2.59 millimeters as the main that reading there. So this is not the answer here because we want the diameter. Okay. They told us that the wire is removed and the jaws of the micrometer are closed. The new reading is shown. So we now look at the new reading before we find the diameter. This is just the reading when we use this the instrument on the wire, and this is the reading when there is no object, but there is no object, but the jaws are closed. So we have to look for a line. That is this line here, which you can see is the one which is perfectly in line with the datum line, with this line here. This line here is the one we are looking for here. So I think it is around here. And this is 10, 11, 12, 13, 14. So it is the 14th marker there. So we shall say the reading there is 14 over 100, which is 0.14 millimeters. That is the reading there. When it is not taking any reading, there's an error of 0.14 millimeters, and that error is positive. And if that error is positive, because when the jaws are closed, the 0 is to the left. The 0 is to the left of the datum line, so the error is going to be positive. So the diameter is going to be 2.59 minus the 0 error, which is 0.114. This gives us 0.45. I mean 2.45 millimeters. So our answer is going to be B. A car is traveling at a speed of 20 meters per second. The table contains values for the kinetic energy and the momentum of the car. Which values are reasonable estimates? Reasonable estimates. The car is traveling at a speed of 20 meters per second. I can use, let me check the momentum using, I'm going to check the momentum using, I mean the mass using momentum. Momentum is mass times velocity. Let me check the first column, I mean the first row. If the momentum is 3 times 10 power 4 and the mass is m, the velocity is v, what is the mass? The velocity is 20. Let me check what is the mass. If the mass is reasonable, then that is a reasonable estimate. 3 exponent 4 divided by 20. So 1,500, I think that is a reasonable estimate for the mass of the car. Okay, let's check. Of course, if I check the kinetic energy, since this is the mass, I will check its kinetic energy. So kinetic energy is going to be a half times 1,500 times the speed, which is 20 squared. Let me check. 1,500 divided by 2 times 20 squared. That is 300,000, which is 3 times 10 power 5. So I think the answer is going to be A. The answer is going to be A automatically. I used momentum to find the mass. Now I checked with the kinetic energy and it is the same value. You could also use the kinetic energy to find the mass and then you substitute to check the momentum. What is the unit of resistance when expressed in SI base units? I think we have already answered this question. So look for an expression that can easily be used to find the resistance. You can use power is equal to I squared times R. That means the resistance is going to be power over I squared. Now use an expression for power that you want. Power can be energy over time. So this will be energy divided by time times I squared. But we have already seen the SI units of energy. So the units here will be kilogram meters squared per second squared for energy divided by time, which is seconds, then times amperes squared in the denominator. So this simplifies to kilogram meters squared. S goes up, it becomes S power negative 3. S squared goes up, it becomes A power negative 2. So our answer is going to be B precisely. Which list contains both scalar and vector quantities? So all these ones are vectors, so that one will be wrong. All these ones, area, current, force, work, those are scalars. Distance, kinetic energy, power, pressure, those are scalars. Mass is a scalar, temperature is a scalar, time is a scalar, speed is a scalar. The question is, which list contains both? Oh, sorry, this one is here. Force is a vector quantity. This one, force is a vector. So this is the correct answer. The answer is B. Area is a scalar, current is a scalar, force is a vector. Force is a vector, work is a scalar. So this one contains both scalar and vector quantities. Vectors P and Q are drawn to scale. They are drawn to scale. If you have a ruler, you can measure. Which diagram represents a vector P plus Q? Remember, they are drawn to scale. So if I bring a vector Q to P without changing the direction, if you have a ruler, you just slide and bring it here. Without changing the direction, you try to bring you slide this vector Q and bring it to the head of vector P. So this is vector Q. You notice that the resultant should be somewhere here. And it is because vector Q is bigger in magnitude than vector P, it means the resultant is not perfectly horizontal. The resultant cannot be vertically downwards. The resultant cannot be vertically upwards. So the answer is going to be A. Join the vectors head to tail by bringing Q to the head of P. Remember, they are measured to scale. Measure from here up to here and try to bring that length onto vector P and try to see what the resultant will be. You can also try to measure the length of these resultants. These resultants in B and D are very small for this combination here. So our answer is most likely going to be A. Which statement is not a reasonable estimate? The atmospheric pressure at sea level is about 1 times 10 power 5. I think atmospheric pressure, we know that from force, density, and pressure. Atmospheric pressure is around 10 power 5 Pascal. That one is a reasonable estimate. Light takes 5 times 10 power 2 seconds to reach us. Yes, that is true, which is about 8 seconds. The frequency of ultraviolet light is 3 times 10 power 12. That is not a reasonable estimate, so this is C. How do you know that? You can try to find the wavelength, because wavelength is going to be C over frequency. C is 3 times 10 power 8 divided by the frequency, which is 3 times 10 power 12. You know the wavelength of ultraviolet after violet. So you have 3 exponent 8 divided by 3 exponent 12. 3 exponent 8 divided by 3 exponent 12. So this is giving us a very big wavelength, 1 times 10 power negative 4 meters. That is a very big wavelength. It can't be for ultraviolet. Remember, violet is 4 times 10 power negative 7. That means ultraviolet should be less than this. It should be 10 power negative 7 or 10 power negative 8. So that one is not a reasonable estimate. The lifespan of a man is about 2 times 10 power 9 seconds. You can change that to years and see. So this will be 2 times 10 power 9 seconds. 1 year is going to be 365 days times 24 hours times 3,600. We are trying to change those seconds to years. So 2 exponent 9 divided by 365 days times 24 hours in a day times 3,600. That is 63 years. That is a reasonable value, but of course not in Africa. In other countries, in Africa, I think it's around 45 on average. 3 of these quantities have the same unit. Which quantity has a different unit? By the way, this was years. I think in some countries like Japan, the lifespan is around 75 and above. Which quantities have a different unit? Energy over distance. Energy over distance. Energy is kilogram meters squared per second squared. Distance is meters. So this gives us kilogram per meter per second squared. Force is also kilogram. Force is kilogram meters per second squared. Then power is energy, which is kilogram meters squared per second squared divided by time, because power is energy over time, divided by seconds. Then again times time, which is also seconds. So this one is kilogram meters squared per second squared. The rate of change of momentum. The rate of change of momentum. Oh, by the way, meters squared over meters is meters, not per meter. The rate of change of momentum. Rate of change of momentum, that is change in momentum over time. That is the rate of change. So the units of momentum are going to be kilogram meters, because it is mass times velocity, kilogram meters per second divided by time, which is seconds. So it becomes kilogram meters per second squared. So this has the same unit as force and energy over distance. So the answer is going to be C. Which group of quantities contains only vectors? Only vectors. Speed is a scalar. Work is a scalar. All these ones are vectors, so the answer is C. An ammeter is calibrated so that it shows a full-scale deflection when it measures a current of 2.0 amperes. A full-scale 2.0 amperes. So I'll use simple mathematics here. 2.0, it gives a full scale, so that means it will give 10. It will show 10 when the current is 2.0 amperes. The diagram shows the display of this ammeter when it is measuring the current. Now, which current is the ammeter reading? So it is showing a certain, the current it is measuring, let me call it X, but the deflection is, this is 6.5. Sorry, this is 7, that is 7.5. So the deflection is 7.5, which current now corresponds to 7.5. I just cross multiply. So I'll have that X times 10 is going to be 2 times 7.5. So X is going to be 2 times 7.5 divided by 10. 2 times 7.5 divided by 10, that is 1.5. So it is reading 1.5 amperes. Which expression has the same SI base units as pressure? The same SI base units as pressure. I think the answer is, remember, pressure is force over area. Pressure is force over area. I think the answer is C, because pressure is force over area. Force over area, that is kilogram meters per second squared divided by meters squared, which becomes kilogram per meter per second squared. So let's check it. C is having mass, which is kilogram, length is meters, then times second squared. So this is times second squared. When these ones go up, it becomes kilogram per meter per second squared. So the answer is C. What is an approximative value of for the speed of sound in the air? Of course, speed of sound in the air is around 300 meters per second. That one you should be familiar with it. In solids, it is approximately 6,000, 5,000 meters per second. In liquids, it's around 1,500 meters per second. This is in liquids. This is in solids. In gases, it is around 330 meters per second. A student wishes to measure a distance of about 10 centimeters to a precision of 0.01. This is a vernier caliper. I have already mentioned that. So without hesitation, the answer here is a vernier caliper because of the precision. For I said a meter ruler measures 0.1 decimal place is the least count. A micrometer screw gauge would measure 0.001 in centimeters. That is the least count. And the tape measure will have almost the same as the meter ruler. A student creates a table to show reasonable estimates of some physical quantities. Which row is not a reasonable estimate? Current in a fan heater is 12 amperes. I think that is reasonable. The mass of an adult person should be around 70 kilograms. That is reasonable. The speed of an Olympic sprinter, I've been using 10 meters per second many times, so that is a reasonable value. The pressure at the bottom of the garden pool, 10 power 6 pascals. This is very small, 10 power 6 pascals. We can try to estimate this by using, we know pressure is force over area. And the force here is going to be the weight, which is going to be m times g, then divided by the area. If only you can estimate a garden pool by area, or you estimate the dimensions, you notice that the mass here will be pressure times the area divided by g. If I get the pressure of 10 power 6 times the area, remember the area is going to be in meters squared, divided by g, then it will give us a smaller mass. So this one is not a reasonable estimate. You can check that. If you know what a garden pond, how big it is, then the amount of the mass of water in it should be relatively large. The particle travels in a straight line with a speed v. The particle slows down and changes direction. The particle slows down and changes direction. The new speed of the particle is v over 2. The new velocity has a component of v over 4 in the same direction as the initial path of the particle. Through which angle has the particle turned? So let's say initially it travels in a straight line with the speed v. It travels in a straight line with the speed v. And then the particle slows down and changes direction. It slows down and changes direction. Let's say it has changed direction and is moving in this direction with a speed of v over 2. The new speed of the particle is v over 2. The new speed has a component of v over 4 in the same direction as the initial. So this one has, I'll change the color. This one has a component in the horizontal, in the direction, the initial direction, and the component here is v over 4. So this is the angle theta. So v over 4 is the component. That is after resolving v over 2. So it means v over 4 must be equal to v over 2 cos of the angle theta. V over 4 must be equal to v over 2 cos of the angle theta, because it must have changed through that angle to reach v over. If the component of v over 2 in the horizontal, in the initial direction of the particle is v over 4, it means when I resolve v over 2 in the same direction as the initial direction of the path, it is going to give me v over 4. So that's why v over 2 cos theta is v over 4. So now I can just check this. It means cos theta is going to be equal to 2 over 4, which means when I press my calculator, theta is going to be equal to 60 degrees, because cos theta is equal to a half, and the cos inverse is going to be 60 degrees. So it means our answer is going to be D. It has moved through an angle of, it has turned through an angle of 60 degrees. The speed v of a liquid leaving a tube depends on the change in pressure delta P and the density rho of the liquid. The speed is given by the equation V is equal to K, change in pressure over rho, or N. K has no units. K is a constant that has no units. What is the value of N? So I'm going here to, whenever they want a power, you just use homogeneity. Speed is in meters per second. K has no units, I will not include it here. Pressure is force over area. So for pressure it's going to be force, which is kilogram meters per second squared, over area, which is meters squared. So meters divided by meter squared becomes per meter. So pressure is kilogram per meter per second squared, divided by density is kilograms per meters cubed. And this is raised to power n. Okay, so kilograms can cancel so that we have peace here. So ms power negative 1 is going to be equal to m power negative 1 over m power negative 3. I think that becomes m power 2. We subtract the powers. Negative 1 minus negative 3, that is positive 2. Then we have s power negative 2, but this is raised to power n. So I can use m to find n. So I have m power 1 on the left hand side and m power 2 times n, which is 2n. So n is going to be equal to a half. If I equate the powers, n is going to be a half. So my answer is going to be A. You could also use s to find n. S power negative 1 on the left hand side is s power negative 2n on the right hand side, where n will still be negative, it will be equal to a half. What is the approximate average speed of a winning female Olympic? A winning female Olympic athlete running a 100-meter race. Because this person is winning, remember we have said a sprinter is running at around 10 meters per second. So I think the answer is going to be precisely B. winning female Olympic athlete running a 100-meter race. So that is approximately 9 meters per second, because it can even round off to 10. Okay, it is very close to 10. That's why. Two forces act on a circular disk as shown. Which diagram shows the line of action? Line of action of the resultant force. The line of action of the resultant force. So I can bring this one downwards. Can bring that one downwards, and that line of action is there. That means the resultant force is going to be in between these two. So it means the line of action, of course, the line of action will be from the center. So our answer is going to be A rather than B, rather than C, rather than D. Why? This line should be closer to 4 newtons than it is to 3 newtons, because this force is bigger than the other one. However, if the turning point, if at the center here is the turning point, if the center is the turning point, it means 4 newtons will have no moment anyway, but is pulling the disk in this direction, and 3 newtons is pulling the disk vertically upward. So the resultant should be somewhere in between these two. That's why I am discarding. Of course, D is automatically wrong. I'm leaving out C, because when I try to look at C and compare it with D, I notice that comparing C with A, I notice that A, the resultant force is closer. The resultant force, the arrow is closer to the direction of the 4 newtons, which makes sense because 4 newtons is greater than 3 newtons. So the answer is going to be A. What correctly expresses the volt in terms of SI base units? The volt is a unit of PD, and we know that PD can be energy or work done per unit charge. Work done is kilogram meters squared per second squared. Then charge is current times time, which is ampere seconds. So it becomes kilogram meter squared per second cubed per ampere, which makes the answer to be D. This simplifies to kilogram meter squared per second squared per ampere. So this is per second cubed. The diameter of a cylindrical metal rod is measured using a micrometer screw gauge. The diagram below shows an enlargement of the scale on the micrometer screw gauge when taking the measurement. What is the cross-sectional area of the rod? Cross-sectional area. First of all, let's see the diameter. Diameter is going to be, the reading on the sleeve scale is 3.5 plus the reading on the thimble scale, which is 30. This is 31, I think 31 over 100, which gives us 3.81 millimeters. That is the diameter. Now that means this is wrong, because the diameter cannot be the cross-sectional area. So let's find now the cross-sectional area. Remember, area is going to be pi d squared over 4. So this will be pi times 3.81 squared divided by 4. So we have pi times 3.81 squared divided by 4. So that is 11.4. So this is 11.4. So our answer is going to be B. What is the best estimate of the kinetic energy of a family car traveling at 50 kilometers per hour? So we have the speed. We just use the energies to check a reasonable mass. And I will just check one, and I think reasonably this is the answer. Let's check if the mass it gives us is reasonable. So kinetic energy is equal to a half mv v squared. So the mass is going to be 2 times the kinetic energy, which is 1.5 times 10 power 5, divided by the speed, which is 50. I have to change this to meters per second. So this is going to be 50 times 1000 divided by an hour, which is 3600. 50 times 1000 divided by 3600. That is 13.9. So this is approximately 13.9. So this is 13.9. I will just use 14 approximately. So I will have that 2 times 1.5. Remember, this should be squared, of course. 2 times 1.5 exponent 5 divided by 14 squared. That is 1500. We have already mentioned an estimate of a curve approximately 1500. So this means this gives us a good estimate for the car, 1530 kilograms as the mass. So this one is going to give us a good estimate for the mass of a car. So that means this is a reasonable estimate. You can check this one to may give you a very small mass, which can't be mass of the car, or this can give you a very large mass, which can't be the mass of a family car. Very large mass, it could be mass of a truck. The diagram shows two vectors x and y. The vectors are perpendicular to one another. What is the magnitude and direction of vector x minus y? So I'm having x, and I'm going to say minus y. That means I'll reverse y to point vertically upwards. So minus y vertically upwards. So it means these are forming an anti-clockwise loop. So the resultant must be the other way around. It will be clockwise. So this is going to be 6 newtons. This is going to be 8 newtons. So the resultant is going to be at this angle. Let's see. At an angle of 37 degrees downwards from the direction of x. Downwards. It can't be downwards because we are reversing y upwards. So this one is wrong. That means this one also is wrong, which says downwards from the direction of x. It is also wrong. It should be upwards from the direction of x. But then at what angle? So opposite adjacent, I think that is tan. So we have theta will be equal to the tan inverse of 6 divided by 8. Tan inverse of 6 divided by 8, which gives us, is that true? This is 37 degrees. So it is at an angle of 37 degrees. So without even checking the magnitude, I know the answer will be B, 37 degrees. If you want to check that the answer is, the resultant is 10 newtons, they are at right angles, just use Pythagoras theorem. So the resultant is going to be the square root of 8 squared plus 6 squared because they are at right angles. So 6 squared plus 8 squared under square root, that is 10. So this is equal to 10 newtons. Which expression using SI base units is equivalent to the volt? I think we have answered that question without wasting time. The answer is going to be D. Which SI unit expressed in base units is not correct? Unit of force, kilogram, that is mass times acceleration, that is correct. Unit of momentum, mass times velocity, that is correct. Unit of pressure, this is mass. Actually, this is the unit of energy. This is not the unit of pressure, so this one is wrong. So the answer is C. The unit of work is the same as that of, sorry, this is not the unit of energy. For pressure, it is force, which is kilogram meters per second squared divided by area, which is meters squared. So this will be equal to kilogram per meter per second squared. It's not per meter squared, so that is wrong. For work done, it's the same as energy, which is kilogram meter squared per second squared. That is correct. So our answer here is going to be C. Two forces, each of 10 newtons, act at a point P as shown. The angle between the direction of the forces is 120 degrees. What is the magnitude of the resultant force? So we want the magnitude of the resultant. You can use resolving. You can use resolving. So if I want to use resolving, it could even be easier if I use this angle here. This angle is going to be, I think, 60 degrees with the horizontal. So using 60 degrees in the vertical, I have 10 newtons in the vertical, will be a vector here, which will be 10 sine 60. In the vertical, it will be 10 sine 60. There is no any other force in the vertical. And in the horizontal, 10 points this side, which will be 10 cos of 60, and there's 10 this side. So in the horizontal, I have 10 minus 10 cos of 60. Because they're in opposite directions, I had to subtract them. Then the resultant will be Pythagoras theorem. So 10 sine of 60, that is about 8.7. And then 10, of course, cos 60 is 0.5. So 10 minus 10 cos of 60 is 5. So this is 5. So the resultant is going to be the square root of 5 squared plus 8.7 squared. So 5 squared plus 5 squared plus 8.7 squared, that's 100.69. Find the square root. It's approximately 10. So our answer is going to be 10. You could use a scale, but that would be wasting much time. In still air, a bird can fly at a speed of 10 meters per second. The wind is blowing from the east at 8 meters per second. In which direction must the bird fly in order to travel to a destination that is due north of the bird's current location? We want the bird to travel to a destination which is due north. So let's say in still air, a bird can fly at a speed of 10 meters per second. The wind is blowing from the east, so the wind is blowing in this direction. It is blowing towards the west at a speed of 8 meters per second. But we want the bird to fly due north. We want the bird to fly due north. In which direction must the bird fly in order to travel to a destination that is due north of the bird's current location? So the bird must fly in this direction, or if we had started it from this side, I'll use a different color for the other end. The bird could be flying, the wind could be blowing from the east to the west, of course, and the bird could be, we want the bird to fly to due north. So if the wind is flowing, there's no way the bird will fly due north unless it is flying at that angle there. So the question is, in which direction must the bird fly in order to travel to a destination that is due north to the bird's current location? So this angle here, it of course to be the same angle with that one there. Okay, so this is 10 meters, this is 80 meters per second, and the bird can fly at 10, so this is 10. So I'll begin by getting the angle first. I will get the angle first. So adjacent hypotenuse, I think that is cos. So theta is equal to cos inverse of adjacent over hypotenuse. So cos inverse of 8 divided by 10. that is 36. So theta should be 36. At least I know that the angle should be 37 approximately, 36.86. That is 37 degrees. So D and C are out. Now the task is to tell whether it will be west of north. No, is it 56? 8. In still air, a bird can fly at a speed of 10 meters per second. The wind, oh by the way, this is 37 degrees. This is not west of, this is 37 degrees that is, this can be read as north of east. 37 north of east, not east of north. Or this one can be read as 37 um, north of west, not west of north. So if I want from the north, east of north, it will be this angle here. If this is 37 degrees, then this is going to be 53. So it means I crossed out one of the correct answers because these ones which are remaining are not making any sense. When I say 50 degrees, 53 degrees east of north, 53 degrees east of north, I think the answer is going to be C. When I say 50 degrees west of north, 50 degrees, 53 degrees west of north. It also makes sense, 53 degrees, because this would be 53. Okay, so I'll rub off this one for one reason. The resultant, when you join vectors head to tail, the resultant will be the other way around. If I join 8 newtons with 10, they form a clockwise loop, so the resultant will be anti-clockwise. That's why I've removed the first part, which makes this one wrong. It can't be 37 east of north, but it can be 37 degrees north of east. Or, yes, it can be 37 degrees north of east, not east of north. That is 37 degrees northwards from the east direction. But now, since this option is not there, so it will be 53 degrees east from the north or east of north, which makes the answer to be C. Which pair of units are not the same? So I got theta, which was from the east, from the west, or from the horizontal, and I had to get the other angle, which is what 90 minus 37. That's why I'm saying 53 degrees east of north. Which pair of units are not the same when expressed in SI base units? From experience, I think because these ones we already know them as units of momentum, they are the same, Newton seconds or kilogram meters per second. Acceleration can also be force over mass, which is newtons per kilogram. Pascals is the same as newtons per meter squared, so the answer must be D. Volts per meter and newtons per coulomb, you can check also that. Volts per meter is not the same as newtons per coulomb, we can check. Volts per meter squared. Volts is the same as, remember, volt is energy over charge. So the units for this is kilogram meter squared per second squared divided by ampere seconds. So the volts, this is going to be kilogram meter squared per second cubed per ampere divided by meter squared. So this one cancels. You remain with the kilogram per second cubed per ampere. Then the newtons per coulomb. Coulomb is the newton is over coulomb. Coulomb is charge. This one is the same as newton is force, kilogram meters per second squared divided by charge, which is ampere seconds. So this one gives, there is a meter already here, which is kilogram meters per second cubed per ampere. So they are not the same. What is the vertical component of this displacement vector? We resolve this in the vertical, and to be 5 sine 37. 5 sine 37, 5 sine 37, which is 3.0. So that is automatically 3.0. Resolving in the vertical, it is 5 sine 37, or it can be 5 cos 53, which still gives us 3.0. The units of specific capacity are joules per kilogram per Kelvin. What are the SI base units of specific heat capacity? So we just change the joule, the rest are SI. The joule is the unit of work done, which is energy. So that can be kilogram meters squared per second squared, that's for joules. Then times per kilogram times per Kelvin. So per kilogram cancels with the kilogram, you remain with the meters squared per second squared per Kelvin, which makes our answer to be C. How many cubic nanometers are in a cubic micrometer? How many cubic nanometers are in a cubic nanometer? So let's first find 1 meter is equal to 1 times 10 power negative, no, 1 nanometer is the same as 1 times 10 power negative 9 in meters. That's 1 nanometer. Okay. Then it means if it is cubic, 1 nano cubic meter will be equal to, we shall raise this to power 3. 1 times 10 power negative 9 meters, but this is raised to power 3. So this means 1 nano cubic meter, 1 nano cubic meter, cubic nanometer is going to be 1 times 10 power. When we raise this to power 3, we multiply 9 by 3, that will be 10 power negative 27 meters cubed. Now we bring in micro. 1 micrometer is the same as 1 times 10 power negative 6 meters. Then if it is cubic, the other side is also cubic. So 1 micrometer cubed, or 1 cubic micrometer, is going to be equal to 1 times 10 power negative, we multiply 6 by 3, so it becomes negative 18 meters cubed. So we now want to change this, we want to change 1 times 10 power negative 27 meters cubed to 1 to micrometers cubed. So we get to cubic micrometers. So I'll just divide this by that. Because if I divide this by 10 power negative 18, it means 1 meter cubed is the same as 1 over 10 power negative 18. If I divide both sides by 10 power negative 18, cubic micrometers. So this means 1 times 10 power negative 27 cubic, meters cubed, is going to be equal to 10 power negative 27 divided by 10 power negative 18 cubic micrometers. So we just subtract the powers. We have negative 27 minus negative 18. That is negative 9. So this is going to be 10 power negative 9. Is it 10 power? What is the other way around? Let me see. We want to change from 1 nanometer cubed is the same as 1 times 10 power negative 27 meters cubed. Okay. Sorry, it is the other way around because I'm changing from a bigger quantity. 1 micro is 10 power so one cubic micrometer is 1 times 10 power negative 18 meters cubed. And when I divide both sides, it means 1 meter cubed is equal to 1 over 10 power negative 18 micrometers. So how many cubic nanometers are in a cubic micrometer? So it is the other way around. How many cubic nanometers? So I started from the wrong end. So I should have started from the other side. So we now have that 1 cubic micrometer is 1 times 10 power negative 3. So it's like we are changing this. Sorry. This is 1 times 10 power negative 18 meters cubed. So we are changing from this to the other one, not the other way around. So in that case, 1 meter cubed is going to be 1 meter cubed from the other one is going to be 1 over 10 power negative 27 nanometer or cubic nanometers, and then 1 times 10 power 1 times 10, because 1 micrometer cubed is equal to 1 times 10 power that. So we shall have that 1 over, because I'm dividing both sides, then it means 1 times 10 power negative 18 is going to be equal to 1 times 10 power negative 18 divided by 10 power negative 27, which gives us 10 power 9. So the answer is going to be C. Okay. If you have a simpler way of doing it, then it is fine, but this is the simplest I can do for you. However, if you know that this one is 10 power nanometer cubed or cubic nanometers, you raise power negative 9 to power 3. So it becomes 10 power negative 27. And cubic micrometers to be 10 power negative 18. So you are changing from this value, this one to that one. So you are going to divide this by the other one. The maximum theoretical power P of a wind turbine is given by this equation, where rho is the density, A is the area swept by the turbine blades, V is the speed of the air, K is a constant with no units. So I will not include K in my units. What is the value of N? So I will just equate the units. P is power. Power is energy over time. So power will have units kilogram, meter squared per second squared divided by time, which is seconds. Then K has no units, I will ignore it. Rho is kilogram per meters cubed. A is area, which is meters squared. V is speed, which is meters per second, but V is raised to power n. So I will just use S to find n. On the left-hand side, S power negative 2 divided by S becomes S power negative 3. On the right-hand side, we have only one S power negative 1 times n, which becomes S power negative n, which means that n is equal to 3. So it means our answer here is going to be C, as precise as that. The prefixes nano, micro, and pico are often used with units. Which row shows their corrective values? Nano is power negative 9. Nano is power negative 9, so A and B are wrong. Micro is power negative 6, so D is wrong. So the answer is going to be C. A crane has an arm to which it is attached a frictionless pulley. A cable passes over the pulley and supports a load of 10 kilonewtons as shown in the figure. The crane arm exerts a force F on the pulley. What is the value of F? So a cable passes over the pulley. A crane has an arm to which is attached a frictionless pulley. The crane arm exerts a force on the pulley. What is the value of F? Okay. So we are going to resolve these forces vertically down along this direction. So resolving 10 kilonewtons and 10 kilonewtons along this direction, that will automatically be cos. So we have 10 cos 30 plus 10 cos 30. I've resolved in this direction here. The angle between is cos. So if the angle is between the vector and the direction you are resolving to, that is automatically cos. So I'll simply say 2 times cos times 10 cos of 30, which gives us 17.3. So this is 17 kilonewtons. So F should be 17 kilonewtons because the F force upwards should be balanced, should be equal to the forces on the other side. So that is F should be 17. The SI unit of specific heat capacity is joules per kilogram per Kelvin. We have answered this question. It's already C because the joule is the same as units of energy, which is kilogram meters squared per second squared. Then I multiplied this by per kilogram, then times per Kelvin. So per kilogram cancelled out with the kilograms, remained with the meters squared per second squared per Kelvin. So the answer is C. P, Q, R, and X, Y, Z are wires in a circuit. A galvanometer connects Q and Y as a null indicator. So the galvanometer will read 0 when the measurement is acceptable. When the galvanometer reads 0, which statement is correct? The potential difference between Q and Y is infinite. That is not true. The PD across this is infinite. That's what it means. The potential difference between Q and Y is 0. That is true. The PD across Q and Y is 0. So there is no potential to be compared in that case. There is no potential difference there. And if there is no potential difference there, then the resultant current through the galvanometer is going to be 0 because when there is no difference in potential, current cannot flow. There is no resultant flow of current in any direction. The resistance between Q and Y is infinity. It may not be infinity. The resistance between Q and Y is 0. It may not be 0. 3 wires each exert a force on a vertical pole as shown. Which diagram shows the resultant force R acting on the pole? Remember to join the vectors head to tail without changing the direction of these vectors. So if I keep the vertical vector constant, I add the horizontal vector without changing its magnitude. Then I add a third vector without changing its magnitude and angle maybe. It means the resultant will be around here. So the resultant is shorter, the resultant is smaller. So this one is giving a bigger resultant. This is also a very big resultant. And if these vectors are forming this loop, then the resultant is going to be the other way around. The resultant must be the other way around. So it means these ones are wrong. This is wrong. This is wrong. So our answer is going to be C. I mean B. If we maintain this in the horizontal and on its head we had this one, then at this one, these ones are forming a clockwise loop. The resultant should be the other way around. Here I had joined on the head of this, I put this vector, then I added another one, and I said the resultant would be, if I had joined them like this and clockwise, the resultant would be the other way around. So the answer is going to be B. Which pair of quantities do not have the same SI base units? I think from experience, because torque is force times perpendicular distance, work is force times distance, that is same unit. Pressure and stress have same units. EMF and PD have same units. The answer is going to be C, because spring constant is force over extension, which is newtons per meter. Then moment is force times perpendicular distance, which is Newton meters. So they are not the same. A lift is supported by two steel cables, each of length 10 meters and diameter 0.5 centimeters. The cables extend by 1 millimeter when a man of mass 80 kilograms steps into the lift. What is the best estimate of the value of the Young modulus of the steel? So we know that Young modulus will be equal to force, which will be the weight, over cross-sectional area, times we get it is Young modulus is stress divided by strain, which is force over area divided by extension over original length. So this becomes original length over extension. So we shall just substitute. The weight is mg, so that is 80 times 9.81. Divided by the cross-sectional area is pi d squared over 4. So this will be pi d squared over 4. The 4 will go up. Then times original length. The original length is 10. The original length is, extension of original length. Then we get the reciprocal. So this will be, original length is 10 over extension, which is 1 times 10 power negative 3. Okay, I'll substitute the diameter when the diameter is 0.5, so I'll just substitute this. This will be 4 goes up times 80 times 9.81 times 10 divided by pi. Diameter is 0.5 times, it is in centimeters, times 10 power negative 2. But this is squared, then times 1 times 10 power negative 3. So in the numerator I have 4 times 80 times 9.81 times 10. So this is 31392. In the denominator I have pi times 0.5 exponent negative 2. This is squared. Then times 1 exponent negative 3. So I'll just get 31392 divided by the answer. So I am getting 3.9 times 10 power 11. Is that okay? So let me check this again. Weight is 80 times G. So this is 4 times 80 times 9.81 times 10. That's the original length, 31392. Divide by, the denominator I have pi into brackets 0.5 exponent negative 2. But this is squared. Then times 1 exponent negative 3. Then I get 31392 divided by the answer. I'm getting 3.99 times 10 power 11. That is approximately 4. 3.997, which is approximately 4. So the answer is going to be D. Okay. Oh, by the way, they said a lift is supported by 2 cables. Sorry, the answer is not D. That is, if I was having 1 cable, now that there are 2 cables, we divide this by 2. It's like having two materials in a parallel. So I will divide this by 2. So divide this by 2, get 1 point that, which is approximate 2.0 times 10 power 9. So the answer is C, not B. Why do I divide by 2? Because if the cable extends, the total extension is 1 millimeter. The total extension is the cable extends by 1 millimeter when a man of mass 80 kilograms steps into the lift. It means if we were to use just one steel cable, that means the total extension will be 2 times 1 millimeters. That is for one cable. For one cable, it would extend by 2 times 1 millimeter. That's why here I would have said extension of 1. Because to find the Young modulus, you use one cable. So extension of one cable will be equal to 2 millimeters. So that's why I'm dividing there by 2. The extension of one cable will be equal to 2 millimeters. Which ammeter reading will be nearest to the true current? Which ammeter reading would be nearest to the true current? Let's check. If the ammeter reading is this one, it is not nearest. If it is this one, it is still not nearest. If the ammeter reading is this one, it is still not nearest. If the ammeter reading is this one, I think this one is nearest because nearest to the true value. If the ammeter reading is 0.8, this is also 0.8. So the answer is 0.8. Which quantity with its unit is correct? Which quantity with its unit is correct? I think this is going to be C. Electric potential difference across a battery. That is, we know that V is equal to energy per unit charge. So that is in joules per coulomb. So that is correct. Electric current in a lamp 0.25 ampere per second. Electric current is just amperes. Acceleration cannot be meters per second. Energy cannot be newtons per meter. It can be Newton meters, but not newtons per meter. The luminosity L of a star is given by that expression. R is radius, T is temperature, sigma is watts per meter squared per Kelvin. What are the SI base units of L? So I think we have answered such a question. We shall not take much time on it. Let's just answer it directly. So L, we want the units of L. So the units of L will be 4 pi will be ignored. R is going to be meters squared. T power 4 will be Kelvin power 4. Sigma will be watts per meter squared. Kelvin power 4. This one cancels, you remain with the watts. So I'll have to change watts to base units. Watts is a unit of power, which is energy over time. So that is kilogram meters squared per second squared divided by time, which is seconds. So this becomes kilogram meter squared per second cubed. So this makes our answer to be C. Which list contains only SI base units? Units, not quantities. Units, not quantities. So Coulomb is not SI base units, so this is out. The Newton is not SI base unit, this is out. The joule and the gram are not SI base units, so this is out. So the answer is going to be the second, Kelvin, ampere, kilogram. The stress needed to fracture a particular solid is given by that equation. E is the Young modulus, D is the distance between the planes of atoms, and K is a constant with no units. So K has no units, I will not include it in the units. What are the SI base units of gamma? So making gamma the subject, I can square both sides and I have sigma squared is equal to K squared into gamma E over D. So gamma is going to be equal to sigma squared times D over K squared times E. But remember, K has no units. So the units of gamma are going to be sigma. Sigma is stress. We know that stress is force over area. So this gives us kilogram meters per second squared divided by meters. So stress has units as kilogram. This is divided by meter squared. So that is kilogram per meter per second squared. That is for stress. But remember it is squared. So I'm going to square it. Then D is in meters. E is the Young modulus. Young modulus has the same units as stress. Young modulus is stress over strain, and strain has no units. So Young modulus has the same units as stress. So this one also has kilogram per meter per second squared. So the units of sigma are going to be kilogram per meter per second squared, but this is squared, times this D, which is distance, meters, divided by kilogram per meter per second squared. So this one is cancelled with the square there. So then per meter with the meter they cancel, and I remain with the kilogram per second squared, because per meter and meters they have cancelled out. So my answer here is going to be B. Vectors P and Q are drawn to scale. Which diagram represents the vector P minus Q? P minus Q. So I think here the answer is going to be C. Let me check. Because they are drawn to scale, I will measure the length of this vector and bring it here. But I have to reverse the direction. So if you have a ruler, you can just slide your ruler from vector Q up to vector P, so that you draw a vector in the opposite direction. So that is negative Q, that is negative Q now. So it means the resultant should be somewhere here. If these two vectors are like that, the resultant is the other way around. So this is going to be the resultant. Therefore, A is going to be wrong, B is going to be wrong, D is going to be wrong. The answer will be C. Remember, they are drawn to scale, so you can measure the length and join the vectors head to tail. So P plus negative Q in the opposite direction. I've reversed Q to point in the opposite direction because of the negative. They form an anti-clockwise loop. So the resultant should be clockwise. That's why I'm taking C. A meter rule is supported horizontally by two pivots as shown. The vertical displacement y at the center of the rule is given by that equation, where k is a constant, l is the distance between the pivots, m is the mass of the rule, t is the thickness of the rule, and w is the width of the rule. In an experiment, the following results are obtained. Which measurement contributes most to the uncertainty in the calculated value of y? So let's find the uncertainty there, the fraction uncertainties. So the fraction in y is going to be for k to be fraction in k over k. K has no what, so I will not include it in the uncertainty. So this will be equal to m fraction in m over m plus, because L is raised to power 3, I will say 3 times fraction in L plus W fraction in W over L over W plus, because T is raised to power 3, I will say 3 times fraction in T. So I'll look at these values and see which one contributes most. So for M, it will be 1 divided by 60. For L, it will be 3 times 0.2 over 80. For W, it will be 0.5 over 23. For T, it will be 3 times 0.1 over 6. So when we check with our calculator, 1 divided by 60, that is 0.02. I'll just write here 0.02. Then 3 times 0. That is 0.6 divided by 80. That is already small, even if I don't write it. 0.5 divided by 23. It is equal to this one. It is 0.02 approximately. Let me check the last one. 3 times 0.1 divided by 6. It is 0.05. So this is the biggest, 0.05. So that means the answer is going to be T. T contributes much because its fractional uncertainty is bigger. What is the order of magnitude of the Young modulus for a metal such as copper? Of course, the Young modulus of metals is of order power 11, so the answer is D. It can't be power negative. Power 4 is very small. Young modulus of metals is 10 power negative 10, 10 power negative 11, 10 power negative 12. The force F between 2-point charges Q1 and Q2 a distance r apart is given by that equation. F is equal to K Q1 Q2 over r squared, where K is a constant. What are the SI base units of K? So making K the subject, K is going to be F r squared divided by Q1 Q2. So let's find the units. F is kilogram meters per second squared because it's mass times acceleration. R squared is going to be meters squared because R is distance. And then charge, Q1, charge is ampere seconds, so it will be ampere seconds and this is squared. So when we simplify this, we have kilogram, meters and meters squared becomes meters cubed. Then S power negative 2 divided by S squared, it becomes S power negative 4. Then 1 over S squared becomes A power negative 2. 1 over S squared becomes A power negative 2. Meaning that our answer is going to be B. An aeroplane can fly at a velocity x when moving through still air. When flying in wind, the aeroplane's velocity relative to the ground is y. So when I check x, x is in the same direction, vertically upwards. Which vector diagram shows the magnitude and direction of the wind velocity w? So when flying in wind, the aeroplane's velocity relative to the ground is y. So y must be the difference between x and another velocity. Or it must be x plus another velocity. Okay. So when I look at these vector diagrams, x plus w in that direction is giving us y. That makes sense. X, this one is showing this is a continuous. So there's no relative velocity here. So this one is wrong. This one is showing that x plus y is equal to w. Yet y should be the relative. So x and y are not joined head to tail. Automatically, x and y here are also not joined head to tail. This one is also showing x plus negative y is equal to w. So here x and y are not joined in a correct way. They are not joined head to tail. So this one is wrong. So this is the only vector which is making sense because x plus w is equal to y. That is, if x and w are forming a clockwise loop, then y, which is the relative velocity, is the other way around. A voltmeter gives readings that are larger than the true value and has a systematic error that varies with the voltage. So has a systematic error which varies. It is not constant, it varies with the voltage. Here it is showing there's no systematic error, so it means C is automatically wrong. The voltmeter is the one which has a systematic error, so the systematic error must be on the x-axis, which is the reading of the voltmeter. So this one is showing there's a systematic error in the true value, which is wrong. It doesn't make any sense. The systematic error must be on the x-axis where there is a meter reading. So we concentrate on A and B. Remember they said it has a systematic error that varies with the voltage, which means our answer is going to be A. Why? This one is showing that the systematic error is remaining constant when you look at this value, this pattern of values. Yet this one is showing that the systematic error is becoming bigger as voltage increases. So the answer is going to be A. The systematic error increases as the voltage becomes bigger. Yet here the systematic error is the same. So the answer is going to be A. The speed v of sound in a gas is given by this equation. What are the SI base units of sigma? So gamma. Squaring, we have v squared is equal to gamma times p over rho. So we have meters. We have gamma is going to be equal to v squared times rho divided by p. The units will be meters per second, but this is squared, times rho is this is divided by p. So rho is the density, so this will be kilogram per meters cubed divided by p is pressure. Pressure is force over area, which is kilogram meters per second squared divided by meter squared. So this becomes kilogram per meter per second squared. So we now try to cancel out some of the things here. Simplifying, this is meters squared times meters power -3. We add the powers, it becomes meters power -1. In the numerator, I remain with s power -2. Kilogram has cancelled. Divide by m power -1 and s power -2. So the question is, what are the SI base units of gamma? You notice that per meter cancels, per second cancels, so we say this has no units. So the answer is D, no units. The motion of an object moving from rest with a constant acceleration a may be represented by the equation v squared is equal to as, which row describes the quantities represented by the symbols v and s. V is velocity, which is a vector. Velocity is not a scalar. S is displacement, which is a vector. So S is not a scalar but a vector. So the answer is D. Both of them are vectors. Which is the SI base unit of, which is an SI base unit? Which one is an SI base unit? So current is a quantity, not a unit. Gram is not a base unit. Volt is not a base unit. So the answer is C. Okay. Okay, so that marks the end of part 4. We have stopped on page 40 in part 4. See you in part 5. Bye bye.